Hi, I'm Craig. Welcome to part 4 in our series on what's new in HEC-RAS 6.0. So today it's a high vis and hard hat day because today we're going to be builders. We'll be engineering some of the biggest dams on the planet, digging some of the biggest canals ever dug, and well, in this video we're going to show you some of the new terrain modification tools that are available, including cloning the terrain and adding high ground, adding channels. We're also going to show you some data sources for acquiring new terrain data. So going back to the model that I started with in part 1, where we took a 3D flight over the Grand Canyon, took a turn at Lake Powell, this time around we're going to go back in and start modifying the terrain to build some dams. Now I used to do this using the raster calculator tools in QGIS. If you Google 84 QGIS, you'll see a webinar where we walk through some of the coding for that. Now what's nice is you can now do that graphically right inside of HEC-RAS. Before we get started, a few other background videos you might be interested in. Number one would be this prequel video. If you just again Google prequel HEC-RAS, you should get to this one where we walk through raster versus vector terrain data, projection files, folder and file management. We also get into the terrain data sources there and look at the guts of what's inside the terrain data, including the no data value. So that might be helpful to watch. Another one would be this 4-part series which we put together a year or two back on terrain modification in HEC-RAS. Most of the steps that we cover in these videos can still be used, but it's a little more efficient now, well, a lot more efficient now with some of the new tools that we'll be covering. But that'll give you some background on it. So to me, one of the most helpful new features was the use of virtual or clone terrains. Now, this data set that I was using for this particular project, and most of the projects I use have very big data sets. This is just a publicly available one. It covers a huge area. Goes over in, well, it's most of the western US, and even when I downsampled this or resampled it to the 100-meter grids instead of the original 30-meter SRTM data, I was still stuck with gigabytes of data. So each of the terrain modifications I was previously making, for each one of them I had to take that data set, which in this case was gigabytes in size, and with every modification I made, it would make copies of those gigabytes of data and quickly fill up my hard drive. And so I would go in and clip out some area and manually extract that and use that for the individual models instead of running it on the whole terrain set. Now, we've got new tools available to us now that allow us to clip out certain areas, and that's very handy. But in a lot of cases, you won't even need to do that anymore because you can work with the larger data set and just clone it. So we'll build 3 dams here, one at the downstream extent of the Grand Canyon, one midway through, and then one at the upper end. And we'll use these new terrain modification tools to do that. So this will be a new dam in between Glen Canyon Dam and Hoover Dam. So we'll be making a new body of water in between Lake Powell and Lake Mead. But I want to keep these options separate so that I can analyze them separately. So in order to do that, I'll show you what I'm talking about with the clone layers. So I'm going to take this large data set here, and we're going to clone this layer 3 times. Once for the downstream, once for the mid, and once for the upstream. So I right-click on it, go to the clone or virtual layer, and enter a suffix name. So the first one I'll do here is called Grand Canyon Downstream. So we'll add that one. So that's now created a copy, but just a virtual copy of it that just links back to the original data of the first one. So I'm going to go back here and clone this again, and in this case I'm going to again call this Grand Canyon, but this time it'll be the middle. So that'll be my middle dam, and then the last one I'll make here is I'll clone this one and I'll call this one Grand Canyon Upstream. So with that, now I've got 3 layers I can work with. So let's zoom in and we'll do the first one, the downstream one. We'll go ahead and block the canyon here using some of these new terrain modification tools. So let's find some high ground we can tie into here. I'll turn off my water and let's go in and start making some modification layers here. So there's the Grand Canyon Skywalk. We'll tie in from the high ground up here over to the other side. So with that, I'm going to start by right-clicking on this clone, which references the same data that's included in my original file. So I'm going to right click on this one and say add new modification layer. In this case, I'm going to start with high ground because the dam is going to be high ground. We'll call this Grand Canyon Downstream Dam, and that'll be our new modification layer. So just in the habit that we should be in with everything else we're doing, from left to right looking downstream, I'm going to go ahead and draw myself a dam from the high ground on the left side over to the high ground on the right side. So when I double click on that, you'll actually see the terrain here. So with this, you can see where it's at, and if I went up to 1500, that would just really send a lot of flow up the other way. So we'll drop this down to just the main canyon down here. So I'm going to make this 1200 on both ends. And when I say OK, I like to keep this update terrain and plots on data change, unless you're working with something really massive. And just to be able to see this thing, we'll make it, say, 200 meters across the top, and at the max on the downstream, on the lower end, let's make this like 5,000, because these are some very big files, or very big areas. So when you do that, what we'll see here, if I turn off my map layers and turn on the modification layer, you can see that it's created for me a dam that's down below the surface. And that might be a little easier to see if I update the legend with view. And if I turn on my contours, I'll make them white here so that you can see them a little better. And we'll make a wider, coarser interval here, and then you can see the dam. So with that dam in place now, as long as you have brake lines going along the top of it, if we go on and rerun it, then you'll see on these results here, I've now got a reservoir that extends way upstream. Let me just pull this back and show you where we go. I'll turn the contours off to make this a little clearer, but you can see that it backs up all the way through the Grand Canyon, all the way up through Lake Powell, and the elevation at the top here, 1200, is actually higher than the elevation at the bottom, way up here, hundreds of kilometers away. So with that, that's what happens if you dam it up just from the main canyon walls at the downstream end. Let's see what happens if we put a bigger dam here across all the way up to the outer walls, and see what happens if that'll push flow up over the side here to the north. So for this case, I'm going to go in and go to my mid terrain. So I'll turn this one back on. It's back to the original. Turn off my results, since I'll rerun this as well. Let's go back here now and make some new modification layers. In this case, you have this option, high ground or channel. It doesn't really matter which one you pick here, because you can change your mind later. If I pick channel and want this going down, let's call this one the Grand Canyon Mid Dam. And so if I want to go in and take that one and make this modification layer, again, these work just like your other terrain layers, or other feature layers that you might want to build. Let's go in here and try and build a dam. Again, looking from the downstream to the upstream direction, left to right. Let's just go across and span the high ground and just go all the way across the canyon walls here. And once you plot that, you'll see the entire thing here. It follows along the existing ground, but let's take this all the way up. And in this case, we'll modify the elevations along the way just to show you how to do that. So we'll bring it all the way up to, say, 1800. And so that's where we're at on the left already. If I go to 1800 here, you'll see it come across. But see how that's low ground? It's going up. Well, I want this going down. Okay, this is going to be the same as what you could have done by going to the high ground to begin with. Just hit higher ground, and now it's going back down. So you see it up at the top here at the max. For this one, maybe we'll make it like a concrete dam and make it really, really steep. Maybe I'll show you also how to go in and add an extra point along the way here. So this chainage or station right here, 1462.03, if I make that at 1800, and then I take something that's midway, say at around 10,000, and I make that one, I guess let's go up there, we could go down, we could do whatever we like. I'll change that one to 1900 and just show you how that can have a little jog in it. Just to make it a little more pronounced, I'll make it a bit higher. And so you can see here, you can bring it up, and you can have as many of these stations along the way as you'd like. And so with that, again, you got to watch out on the maximum extent at the bottom. Make sure you're out far enough where it covers the entire thing. Otherwise, it just goes vertical at that point. And if I hit OK now, this is a very narrow width. with, you'll see that this one comes out a little differently. Our last one, if it was earthfill, would come way out. In this case, you have to zoom in to see it, and you can see our terrain there. It's very steep, but if I come in here and double click on it and see the terrain profile, you can see that there's a dam there. So let's run that one and see what happens. And if we block this off, where's the flow going to go from here? So I'll zoom out to the same extent as before, turn on my map layers for reference, and now let's look at these results here for the mid Grand Canyon Dam, and this will be under my results. Turn on the mid one, and then you can see here, if I've blocked it up at this point and I let this go, let me turn off the geometries so we can see what's going on here, and I'll turn off the geometry in this one as well, and watch this thing as we animate it, bringing the same flood back through as we showed previously, this big paleo flood. It starts heading down the Grand Canyon. Now I'm blocked all the way to the canyon walls here by the terrain. Again, you got to make sure you have break lines along that narrow canyon or narrow dam wall. But if you have a look at that, it's actually sending some flow back up through the Grand Canyon the other way. So we have successfully dried out this area, if that's a success. But again, that's just something we can play around with in the terrain modification tools. So for the next exercise, let's go up to the upstream area here. You've probably seen Horseshoe Bend in a number of tourist photographs of the area. Let's go ahead and block the canyon there and see what happens. We'll actually build ourselves a diversion here as well. So this is Lake Powell. This is where the dam currently is up here near Page, and here in Marble Canyon, we'll just go ahead and block it off right there, and you can see that that will then push the water up this way. So it wouldn't take much to excavate. Well, it would take a lot, but relative to the Grand Canyon, it wouldn't take a lot to put a bypass in up around this area right here. And that'll give us a chance to practice the terrain modification tools in cut as well as in fill. So I'm going to turn the contours back on here in our third layer. This is again a virtual layer. Only the HDF files have to be saved along with the original terrain. Do not start messing around or moving around the original terrain data. This still links back to that, so you'll lose the clone if you lose the original, so watch out for that. So again, on the western US terrain, the original one I started with, I'm going to add a new line, and in this case I'll start again with high ground, and we'll call this one Grand Canyon Upstream Dam. And this one's going to go back in as fill the same way the other ones did, but then I'll show you how to use polygons later on and some other features that are pretty cool. So with this, just to tie into the high ground, again I'll turn on the contours. I'll put them at a 20-meter resolution, again make them white so they're a little easier to see. And in this case, I'm going to tie this high ground in right there. So there's Horseshoe Bend right there that you can have a look at. I'll just block the whole canyon right there. So with this, again, same as we did before. And it's grayed out because there's nothing in it yet, so we'll just add some features to this. Again, I'll go from left to right looking downstream and just go right along here along this canyon wall and double click there, and we'll see this profile plot. In this case, again, if I left it at 100, it's going to end up as a vertical dam. So let's go out here. I'll make it a maximum, say, of 5 kilometers wide across the base. I'll make it 500 meters wide across the top, just so you can see it. And we could make this as mild or as steep as you'd like to see, and adjust the elevations as you'd like. If I hit OK there, you can see this terrain now, and when I zoom in on it, you should be able to see the contours of the dam itself. That goes right across Lee's Ferry there, and what's going to happen now is we'll back up the water into Lake Powell, and then what I'm going to do is connect that to a diversion up the other way here as a channel. So I'll save this one, stop editing and save this one, and what I'll do now is add another modification layer, and in this case I'm going to go with a line that's below ground, a channel, and we'll call this one Grand Canyon Bypass. And so with that, I could go in and make a layer here, but what I'm going to do is just make a dummy layer for now. I'll connect it from the east to the west here, from actually I don't want a control point, I want it from there to there, and when I put this in, you'll see this here, but what I'm going to do now is replace it with a shape file. So I'll keep this as it was, and I'll go up here, and this could be a shapefile that you already have from some other project and that's already been created. I'll create it right here under features. Again, you can create shapefiles under map layers. You can also create shapefiles as profile lines and save them that way. I like to do them here if I'm just going to make a generic one. I like to just create it under features. So I'm going to make a new polyline layer, and I'll call this one Grand Canyon Bypass. And so this will, under the features folder, it will create a new file called, or shapefile called Grand Canyon Bypass. So where are we going to pick this one up here? If I try to be a builder, where would it make sense? I'll pull into some of the low ground up in here. I might start from this channel as we get backed up. I think the water is going to come up this way. So I'm going to start right about here and try and follow the low ground, try and keep our costs down in this. This would be a mighty expensive project. I could come up here, and maybe I should have gone around that way, but I'll just cut right through this and come over here into the low ground over this way and follow around to wherever we drop off the canyon walls over here. Let's see, if I go over this way, you'll see, yeah, I'll take it all the way out here, and again, just for fun, we'll take this around like this and drop it down the hillside here. So once I've done that, I've got the shapefile. Now I'll right click and stop editing, and now it'll be saved as one of my features. So I'll go back to the feature that I was drawing here as a terrain modification tool and replace what I had before with this one. So I go in here and go to this Grand Canyon one, start editing the ground lined modification. And in this case, I've got a line there, but I'm going to blow it out. And it's going to warn me about that. Yep, I want to blow it out. Where is it? I like this little preview window they've given us here. I'm going to go in under features, and I'll see Grand Canyon Bypass created today. And that's the one I've just made. And when I import that, I now see the new bypass channel. So this was my start, this was my end. So I can go in here now. You got to watch out though, if I've replaced this, I also need to change my polyline length. It'll warn me if I don't. I don't know if there's a way to do this automatically, but I'm going to replace it like this and say it'll take a while. That's fine. I can change this back to updating the terrain while I do that. It shouldn't take too long on my part. But again, I had it going the other way before, so I'm going to take this one from an elevation of, say, 1250. So I'll take this one here, make it 1250, and then down at the bottom end here, I'll make it 1000. And in this case, again, I just do everything like I did with the dam, but I'm going to do it upside down. So with that, I should see a channel now going from one end to the other. And again, this is not higher value. If I made this as a dam, it's going to be the higher value. If I select this as the channel, you can go down to the lower, and now it's going to flip it upside down. Okay, so I can change my side slopes. I can make these vertical. Again, just to see it, I'm going to make this one 500 meters. Oh, I'll make it 1,000 meters wide. Actually, I'll make it even bigger, 5,000 meters wide across the bottom. That way we'll be able to see it. My maximum extent across the top, let's make this 20,000, and this is going to be a massive channel. You'll see this thing get excavated right through the terrain there. You see that? So now if I've got my contours here, this you can see how big this is relative to the Grand Canyon. When I run the flow through here, it'll back up this way, send the flow around into Lake Mead from the north. So let me turn off my contours so we can see this a little better, and then we'll turn on the water and you can see what this looks like. So we'll stop editing that. I'll say yes, and let's go in and have a look at these results. This one's not quite as big as from an earlier run, but I'll show you this anyway. If I come back up here and go to the results, here's my depth. I'll back this off again. And again, this is the same flood I showed you before that was backing up in the Grand Canyon itself. And as I bring this through, now it hits this dam at Horseshoe Bend, and routes everything through this diversion channel, starts backing up through the Grand Canyon itself, but the Grand Canyon stays dry. So again, not something you would ever want to do in real life, but it's fun to do, just like playing with dams in the sand as a kid. This stuff can be, you can have a lot of fun with it. So let's take this down to a more realistic scale. And again, I had this terrain that covered the entire western US here. What if I wanted to go in and do something that's outside of here? I will show you how to go and pick up new terrain. One of the dams that I've had a look at in some dam failure scenarios is the St. Francis Dam, which is just outside of, well, upstream of Ventura, which failed and ended the career of William Mulholland back in the day, and there's nothing left of it today. So again, there is the Castaic Lake and Castaic Dam just downstream, but if you go to where the St. Francis Dam was, there's nothing there now. Behind this, I have no terrain. So I did want to show you briefly how to acquire that terrain if you wanted SRTM data that's free everywhere on the planet. Let's go through the process of acquiring that, and then we'll try putting this dam back in and see if we can do something on a more realistic scale. So EarthExplorer is a great site. If you wanted to just Google that, you will need an account, but when you put this into Google, it'll take you right to the site. And in this case, it'll take you to a map. I'll show you just for kicks here in Australia what I've done here in the past to grab all of the terrain data that I use as an initial overview. This is satellite based, but if I just use the map as the coordinates, then that's what I get, all of Australia. And so under the data sets, you can see digital elevation maps here. You do have to go click on SRTM. I'll grab the regular ones. You could get hydrologically enforced ones as well. But when you look at the results, you'll see 843 tiles. If you're gonna work here frequently, maybe you wanna download them all, or you can pick which ones you want. So again, panning back over to where our area of interest with the St. Francis Dam, this is in the Los Angeles area. Again, if I use this map, what I'm looking at right now as the coordinate extents, this will overlap with some of the tiles. So when I go to the data sets and pull my SRTM data from there, look at the results, it's going to show me for these tiles. You can preview the footprint and see where those are. If we zoom out, I think it'll take 4 of them here to cover the entire area that we're looking at. And then you can move over to the download. And once you've got the download options selected, choose your GeoTIFF, that's what HEC-RAS will read, and then it'll just copy over to your computer. So coming back to our RAS Mapper project here, I'll open this up and I'm going to put a new terrain in here, and I'll grab these 4 tiles. Now I did have to go in and reproject these. I used QGIS to do that. I'm just putting them in the same coordinate system that we're in here. I will, in this case, merge these into a single raster. Only do this if you are tiled at the same resolution or roughly the same resolution. And so I'm going to go in and call this one under terrains. I'll double click on that, set the folder name, and we'll call this one the merged SRTM, and this will be St. Francis. So for that area, once I click save, I can create this, and then we just watch it do its thing. And once it's done running through it, it will have created now a merged SRTM terrain file that we're going to use going forward. So now when I zoom in on this area, let me go to the St. Francis Dam. Now when I turn off the map layers, you'll see I have some terrain data. Let me just turn on the update legend with view so we can see a little more here. This is the location where the dam used to be. Get your gun center there in true American fashion. If you want to take your military style assault rifle up there and shoot some things up, you sure can. Just down the road, you've got Castaic Dam, and I'll just show you as a reference one of the common things that you'd want to do with terrain modification this has got the water surface in the LiDAR data or in the satellite data, and you may want to remove that if you're going to route something through it. So we've got a dam in place that you may want to remove, either the dam so that you can do a dam breach study, or the reservoir behind it so that you can use that storage in a 2D model. In our case, though, there's a dam missing that used to be there and that we'll go ahead and try and put back. So with that, I'll turn on these map layers. This, I think, is one of the old abutments of the dam. So let me just turn this one back off again, and we'll just review the steps that we talked about today. Add a new modification layer, line. I'm going to make this high ground. I'll call this the St. Francis Dam. And when I put this in, then left to right, looking downstream from one abutment to the other, I can add this in, again, make any changes I want to. I'll make the base a little wider if I need to. I'm not sure how big that top width used to be, but you could go try and match this thing, and maybe it was probably flat. Maybe it's at a 600 elevation. I'll pull this in here, and we'll just see what this would have looked like. So with that, you can see the dam there. I could put some contours in. Looks like I probably should have gone wider. Maybe it's too wide up at the top. But one thing I wanted to point out here is that my data, my terrain data, is probably not good enough for a dam breach study, for anything that's going to use this channel. So what if you needed a little more resolution on your LiDAR data? A lot of times you might get this from your client or from some of the stakeholders, but what if you didn't have any? In this case, luckily in the LA area, it has been flown and it's available publicly. So let's do another Google search here and we'll pick that up. So in this case, I'll just Google Los Angeles LiDAR. And if you do that, you'll get to this data set here that's covered by NOAA fisheries, actually. Scroll down and we should see the coverage area for this particular data set. And again, you'll have similar things available elsewhere on the planet. Here's one I'll just open up in a new link that shows you the viewer that NOAA uses. And you can see the coverage area. Now, in this case, let me just grab some high resolution terrain data extending from, well, that's Hollywood, the Hollywood sign there, Hollywood Reservoir, and all the way down to the LA River, the famous site that you'll see in a lot of these movies. If you go to elevation data, I can grab the one that's less than 1.5 billion points. That's the DEM data, and this will be at I think a 1 meter or 3 foot resolution, I believe. And there's your coordinate system, and all you got to do is just put in your information there. So once I've added that, then I can go in and extract that data by just hitting the toggles here and hitting submit. Now I'll back up and cover this one more time just to show you some of the other options you've got available to you. Again, last time I grabbed this DEM data. You could also grab some of the raw data as well. So, but again, in that case, you're limited to, I think, 1.5 billion points. The area I just picked there was 2.1, so that's a little too big. I'll choose something a little smaller and extend out our coverage area just to the LA River here. And that's still a little too big, 1.6. Let's make this 1.3, 1.4, that's good. Okay, so when I add this one to the cart, it's actually gonna ask me a little bit about the projection. And I am gonna put this into meters and go ahead and pick all points instead of just the ground points. I'll show you the difference. I'll grab a couple of these and show you the difference. The grid size here is 0.5 meter, so it's a little higher resolution than the previous one, and I'll show you the difference between these. So once you submit, you get an order number and just log into your email and you should be able to download that zip file. Each of these are about 1 gigabyte in size. So I'll pull some of the terrain data that we just downloaded back up here, and here's where we really get to have a lot of fun with it, because this is some great data. You can see here I've bookmarked a whole bunch of views here on some movie sets, and I think I'll save the rest of the terrain features, some of the more advanced features with putting in control points and other polygons and removing no data values and all that. I think I'll just put that into a separate video and stop this one for the day. But I'll give you a little preview of what we'll do then. Again, let's zoom into the LA River, and I'll show you how good this data set is and really how bad the SRTM data is. So if I take this, this is the LA River in Greece. In other movies, you've seen them race along this. I think they come up here and go around this bridge and come back down in Greece. Maybe we'll do a flight path on that one as well. Again, you can see then when I turn off the map layer that this is some pretty high resolution data. But when I cut across here, you'll see that the LiDAR data down to the 0.5 meter resolution, you can pick up the low flow channel and everything else. Look at the SRTM data, and that's pretty common that it's off that far. So again, don't use SRTM data for your hydraulic analysis. It might be good for watershed or catchment delineations, but it's not going to help you with some of these things that we want to do where we dive into a little more detail in the terrain modification. So we're going to have some fun with it. If you've got suggestions on things that you would like to see us do with terrain modification, let me know. I'll highlight a couple of these spots on our next video, and what we'll do is just dig out some swimming pools for the poltergeist house, and maybe we'll go in and put some bridges back. I'm excited about these new features. They really do save a lot of time. Please subscribe and give us your feedback. This is about you and what you think is most useful for your work. Thanks a lot. Signing off.